All right, let's look at a few more examples to finish off our chapter 3. So let's say we have a bag that contains 13 marbles. Okay, there's 5 marbles, 5 blue marbles, 6 red marbles, and 2 yellow marbles. If you are a visual person, you are always welcome to draw out this situation to help you visualize what's going on. There's 5 blue, 6 red, we'll just do this orange instead of yellow, and 2 yellow. All right, this is what's happening in our total bag. Okay, this is a bag. What's the probability of pulling out a blue marble? So in my bag, you have to think that these marbles we're assuming are all the same size. We have equal probability of pulling out any of them. So to pull out a blue, let's just call it B for blue. The probability of pulling out a blue is out of how many options could we pick a blue one? So let's think of how many there are total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 marbles. So out of 13 marbles, there are 1, 2, 3, 4, 5 different ways to pull a blue marble. What's the probability of red? Well, 1, 2, 3, 4, 5, 6 out of 13. Yellow, 2 out of 13. All right, what if I wanted blue or yellow? Well, there's 5, 6, 7 different ways to get blue or yellow. So 7 out of 13. Which, look, I just did part B, right? Red or yellow. You can do this kind of 2 ways. So the probability of pulling out a red or yellow, I just counted. I know I did blue or yellow, but red or yellow is 6 red or 2 different yellows. So that's 8 out of 13. Okay, if you're just looking at it logically, you can count the different ways. But it's important to kind of note that our formula way was the probability of red plus the probability of yellow minus the probability of red and yellow. All right, but notice that there's absolutely, if I'm picking one marble, there's no way that I could pull one that's red and yellow simultaneously because those are mutually exclusive events. They're fully separated. It's impossible to pull the same color, the same marble that has 2 colors because they are all individually colored marbles. So setting this up, it is that same way. Red was 6 out of 13. Yellow was 2 out of 13. And you could not have pulled the same. Red and yellow was impossible. So it is that 8 out of 13, which we could have found by just counting. There were 6 red, 1, 2, 3, 4, 5, 6, 7, 8. 8 different ways to pull a red or a yellow. All right, a marble is drawn from the bag and then replaced. So this is the time where I get to talk about with replacement and without replacement. All right, with replacement means visually, I take a marble out and then I put it back before drawing another. So before we did a small section where we had independent probability and talked about multiplying the probabilities together. Okay, those were independent of each other. So basically in this situation, that would be our with replacement. Okay, meaning that if I pick a marble out from the beginning and I put it back, it doesn't change the probability of selecting a different marble or the same marble in the next round. So when we do this, I like to just kind of lay out the slots to talk about each individual probability. So our first pick, we're drawing 2 marbles here. First draw and second draw. And we're going to multiply these probabilities together. So we pull out a marble. We were hoping for a yellow. Well, what's the probability of pulling out a yellow? 2 out of 13. Now, it's important to see that here we put the marble back. So that was us pulling out the yellow, but we're going to throw the yellow one back in before we pull out another. Okay, so it's still out of 13. Okay, now what's the probability of pulling out of red? Well, it's 1, 2, 3, 4, 5, 6 out of 13. Right, and we multiply these together. First draw or first pull, second pull. We get 12 out of 169. Right, or if you put that in a calculator, that's 0.0710. All right, what if we don't replace the marble? So again, 2 draws. The first draw, we want the probability of pulling out a yellow. Okay, well, there's 13 marbles in the bag. That's 2 out of 13. But now we don't replace the marble. I'm holding this marble now. So I pulled that yellow out, and look at my little picture up there. I pulled the yellow out and I'm holding it. What's the probability of grabbing a red? Well, now it's out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Out of 12. How many ways could I pull a red? It's still 6 out of 12. Holding the yellow didn't change how many ways there were to pull a red, but it did change the total number that we were selecting from. So this is what we would multiply across. 6 times 2 is 12. That's where that's coming from. 13 times 12 is not 169 anymore. It's now 156. Put this in a calculator and we get 0.0769. So a slight increase in probability when you do not have replacement, because now there's less to choose from to accomplish that task.